US Physics Olympiad, year 2012. F equal MA, first round. Problem number 17. Shown below is a log by log plot for the data collected of amplitude and the period of oscillation for certain nonlinear oscillator. According to the data, the relationship between period t and amplitude A is best given by such equations. Solution. If we look at this graph, log by log, we can write equation which is corresponding to this graph. Slope for this graph is 2, and for log A equal 0, log t equal 3. So it means that this equation must look like this. Log t equal 3 plus 2 times log A. Now let's put 10 in the power of both of these expressions. So we have t equal 1000 A square, which is answer A. Problem number 18. A mass hangs from the ceiling of a box by an idle spring. With the box held fixed, the mass is given an initial velocity and oscillates with a purely vertical motion. When the mass reaches the lowest point of its motion, the box is released and allowed to fall. To an observer inside the box, which of the following quantities does not change when the box is released? Ignore higher resistance. Solution. The only difference between box in first case and box in second case when it has a free fall, that point of equilibrium has a different position. In the second case, when box is released, when mass in lowest point, the point of equilibrium moves up. It means that amplitude is increasing. And because we have ideal spring, the period must be the same. Let's check the answers. The amplitude of the oscillation. That's not true. Amplitude will increase. The period of the oscillation. That's true. Period will be the same. C. The maximum speed reached by the mass. Maximum speed will increase because amplitude will increase. D. The height at which the mass reached its maximum speed. Yes, that's true, because maximum speed will be in position of equilibrium, and the position of equilibrium will change. The maximum height reached by the mass. This position will change because amplitude will change. So correct answer is B. Problem number 19. A 1500 watt motor is used to pump water a vertical height of 2 meters out of a flooded basement through a cylindrical pipe. The water is ejected through the end of the pipe at the speed of 2.5 meters per second. Ignore friction and assuming that all of the energy of the motor goes to the water, which of the following is closest to the radius of the pipe. The density of water is ρ equal 1000 kilograms per cubic meter. Solution. We can count power by regular formula. Power equal force multiplied by speed. In our case, force equal force of gravity, and this is how a column of 2 meters high move up with a speed v equal 2.5 meters per second. So we need to multiply weight of this column by speed. That will be power. Pi r square h, that's a total volume of this column of water, multiplied by rho, that's a total mass of this column, multiplied by g, that's a weight, or that's a force which produce this motor, and the force multiplied by speed, that's a power. And from here we can find what is r square. R square equal power over v pi rho g h. When we put numbers, we have this expression which is equal approximately 0.01. So to find what is r, we need to get a square root from this, and that will be r equal 0.1 meters or 10 centimeters, which is answer D.